Yeah, welcome you back to the session on the Z transforms. So in the last class, as you all know, we were finding out the Z transforms of some basic signals. Fine. We have found out the Z transform of sine omega naught n, that is one of the sinusoidal sequence. Another sinusoidal sequence is cos omega naught n u of n. Fine. So how to find out x of z and what will be the ROC for this? Okay, the ROC would here also be greater than 1. Understand that? So this you will do yourself. It's very similar to what we have done for sinusoidal sequence. That means sine omega naught n sequence. What did we do? We have sine omega naught n, and that was expressed as this e power j omega naught n minus e power minus j omega naught n divided by 2j. So what would be the difference for cos omega naught n? Anybody? What is cos omega naught n? Cos omega naught n will be e power j omega naught n. It would be plus e power minus j omega naught n. Then the denominator, instead of 2j, you'll just have 2. Fine. So this you will bring in place of cos omega naught n. So when you're finding it for cos omega naught n. Understand that? Okay. So this is how we proceeded from here on. Okay. So on the similar way, we have to be finding out the Z transform of what? Cos omega naught n also. So this is the hint. Fine. So you will write the equation for x of z. X of z is what? Summation what? N ranging from minus infinity to plus infinity, x of n, z to the power minus n. In place of x of n, you will have what? Cos omega naught n. Okay, and this is z power minus n. And in place of cos omega naught n, you will bring this. So it is going to look like this. 1 by 2 we can keep out, or since we are substituting it for the first time, let's substitute it properly. Minus infinity to plus infinity, e power j omega naught n plus e power minus j omega naught n divided by 2 into z to the power minus n. Understand that? So this is how the things go. Okay. So do this as we have done it for sine omega naught n, which you already have seen, and get this answer. Fine. And ROC, where do we find out ROC? We find out ROC soon after we solve this particular summation. Soon after the summation is solved, we find out our ROC taking this into consideration. Then this equation is written in terms of Z. This equation is in terms of Z inverse. Okay, this is where we'll be finding out ROC. So soon after this summation is solved, okay, we find out the ROC, and once we get our ROC, we again further go to express this equation in terms of Z. So this is how it becomes. Fine. To do that exercise, it's quite interesting, and you'll learn also. Fine. Otherwise, it looks repetitive. Let's move on with some more problems. Okay. So take down this heading now. Find the Z transform. So we have found out the Z transform of delta of n, u of n. Okay. So we can also find out the, there is one more thing that we can do here. The ramp function also we can have. You know ramp function, right? What is ramp function? In this is let's find out the Z transform of unit ramp function or sequence. Okay, so let's see, this is x of n. It would look like what? R of n is your ramp, since it is ramp function. Okay, how we can write this? We can write this as n into u of n, or what is this? It is n for n greater than or equal to 0, and 0 for n less than 0. This is what is ramp function. How the equation for ramp function looks like, or how the z transform of ramp function looks like. Okay, so z transform, as you all know, is given by what? X of z, right? So x of z equal to summation n ranging from minus infinity to plus infinity x of n into z to the power minus n, right? So let's bring this in place of x of n, that is n into u of n z to the power minus n. Since this u of n is 1 for n ranging from 0 to 1, this can be further written as n ranging from 0 to infinity, sorry, okay, 0 to infinity, n into z to the power minus n. Understand this? So this can be further written as this. What is it? So this is n u of n, and n is here, z to the power minus n is here, right? So this can further be written as, therefore, x of z can be written as this. See, this is another standard form which we have not come across so far. That is n into z to the power minus 1 to the power n. So this is what is the form. Okay, so we know that there is a standard form which I'm giving you now. Summation n ranging from 0 to infinity, n into a of n is what? What we know is this here. Summation n ranging from 0 to infinity, a power n is known when a is less than 0. What is this? Anybody can tell me what is this going to be? What is this? It is 1 by 1 minus a. Understand? So instead of that, if you bring in n here within the summation, then it is a by 1 minus a whole square, because this n is there. Understand that? Therefore, x of z can be written as what? It can be written as what? Z inverse is a. This is a, right? So in place of a, you have z inverse. That's it. So it is z inverse divided by 1 minus z inverse whole square. Understand that? So here we need to see for ROC. There are two 1 minus z inverse here. That 1 minus, so this is 1 minus z inverse into 1 minus z inverse. So if you see it for one, the same applies for other parameter also. The two terms are there. Do it for just one term. That is sufficient. So here we shall see ROC. Then we shall express this again in let me call this as equation number 1. Every time soon after the summation is solved, I will call that as equation 1. And at this point of time, we shall find out the ROC, and then we shall go for expressing this equation number 1 in terms of z. This is in terms of z inverse. Let's express this in terms of z after we find out the ROC, because ROC needs to be found out at this point of time. Okay, so to find ROC, what do we say? To find ROC, anybody? 1 minus z inverse, the magnitude of 1 minus z inverse should be greater than 0. So that is when x of z is finite. Understand that? So for this to be finite, this denominator has to be greater than 0. Should not be 0, because if it is 0, it is infinity. So it should be magnitude greater than 0. So it means to say 1 is greater than Z inverse, or 1 is greater than 1 by Z, or magnitude Z is greater than 1. So this is your ROC. Fine. So therefore equation 1, how can I express equation 1? Therefore equation 1 implies x of Z is equal to, this is 1 by Z, fine, and here you have 1 minus 1 by Z whole square, right? Further it would look like 1 by Z divided by Z minus 1 by Z whole square. Understand that? So you have 1Z here, so this can be written as what? 1 by Z, okay, then Z minus 1 whole square divided by Z into 1 by Z. Okay, so these two go off, this and this goes off. You'll be left with, therefore x of Z is Z by Z minus 1 whole square with ROC, okay, magnitude Z greater than 1. Everybody understand this point? Okay, this is what is the Z transform of the ramp function. Everybody understand that point? This is Z by Z minus 1 whole square. Okay, if it is, let me just tell you, if see Z transform of U of n is, or let me say, Z transform of A par n U of n is what? Z by Z minus A with ROC Z greater than A. Okay, so this is Z by Z minus 1 with ROC Z greater than 1, because A is 1 here. In place of A we have 1, so this A is 1. So this A is 1. Understand? So similarly, what we have done here is, if you have an extra n, what would be the difference? It is Z by Z minus 1 whole square with ROC again outside the circle with radius 1. So these are all standard transforms, very similar transforms also. Is this okay with you, everybody? So these are some very important transforms of the basic signals. Okay, the signals we have seen so far is U of n, A par n U of n, minus B par n U of minus n minus 1. It's not here. If you write that here, it's different. Okay, so let me just give you that as another example. It is this. Fine, so we have seen it for n U of n. You have seen it for delta of n. You have seen it for sine omega naught n U of n. Okay, and I've also asked you to do it for sine cos omega naught n U of n. And since all this we have seen, so these are all basic signals, and on them we have applied the transforms. Understand? Now let me just let me just go further and do some problems on this. Now, one more thing that I want you to give is, suppose you have this. What is the Z transform of this? This is negative time exponential, mind you. So what is the Z transform of negative time exponential? You have done this in the internals also. Anybody would like to give me the answer for this? Z transform of this. Or this can be written in this way also. So the Z transform, these are called as Z transform pairs. Okay, the Z transform this is given by Z by Z minus B, okay, with ROC, okay, inside the circle with radius P. Okay, this is what we understand for this. Suppose you are given this. Suppose this minus is not there. How it would look like? Can you tell me? Suppose that minus is not there. Anybody? Suppose that minus is not there, means it would be minus Z by Z minus B. ROC would remain this inside the circle with radius B, because the denominator will not change. You understand? And now, if it is minus of minus B to the power n, U of minus n minus 1. Can you tell me what is the Z transform of this? Anybody? Say I've associated a minus not only outside this bracket, but inside this bracket also have a negative sign. So what would be the Z transform of this? Seeing this, can you tell me that? So here B is positive, here B is negative. So in that sense, this B would be negative. Okay, so it would be Z by Z plus B, whose region of convergence would be within the circle with radius B. Fine, so this is all interdependence. Fine, if minus is not there, here this is the standard Z by Z minus B. If this minus is not there, suppose it would become minus of that. So this minus would reflect on the other side of the domain. Fine. So if you have minus outside as well as inside, if you have this B is positive B to the power n is Z by Z minus B. If it is minus B to the power n, then it is Z by Z plus B. So this B has to be negative. Okay, so if this B is negative, it would negative of negative B would become plus B. Understand that? So all the small adjustments you need to make if it is modified like this. The same standard transforms could be given with these modifications. Understand? So you need to be a little careful with that. Fine. So with that, let's move on to some more problems. Fine. Take the heading as this. Find the Z transform. Find the Z transforms of following sequences and sketch ROC. So they are very particular in asking us to sketch the region of convergence. Is it okay with you? This is what we are supposed to be doing now. Fine. So let's go and take these problems one by one. The first problem that they have given us here is x of n equal to 0 for n less than 0. It's 1 for n greater than or equal to 0, less than or equal to 9. And it is again 0 for n greater than 9. So can you tell me the range of this signal? Anybody? Can you tell me the range of this signal?
1 from 0 to
Who will
9.
give me the range? Anybody? It's very clearly said there. See, it is 0 for n less than 0. That means from minus infinity to minus 1, it is 0. And it is 1 from 0 to 9 because it is n greater than or equal to 0. So from 0 and n less than or equal to 9. So from 0 to 9, it is 1. So this is ranging from 0 to 9. Understand that? So it's a finite sequence, mind you. In the solution, let's identify the sequence as the finite sequence. X of n is a finite right-sided or left-sided sequence. This is anybody? It is finite right-sided sequence. Right-sided sequence, or you can call it as causal sequence. And we know for causal sequence, okay, what is the region of convergence? What is the region of convergence? Anybody? Region of convergence is the whole plane except z equal to 0, right? So that we shall see now how that would be possible. Okay, so what is the x of z given by? So let's consider x of z. Fine. So it's summation n ranging from minus infinity to plus infinity. X of n z to the power minus n. And x of n is 1, mind you. Okay, x of n is 1. Okay, from n equal to 0 to 9. That is what is given here. X of n is 1 from 0 to 9. That's why I've taken it from 0 to 9. For all other values of n's, it is 0. Okay, so that is why the x of z would look like this. Fine. So further, it can be written as what? Further, it can be written as summation n ranging from 0 to 9 z to the power minus 1 to the power n. Can anybody give the solve this summation? So this is a finite summation, mind you. Can anybody give the value of this summation? Let's see. Anybody would like to give the value for this particular summation or solve this summation? Seeing this is standard summation. Anybody would like to attempt that? Somebody should do that. This is the biggest problem we have. No interactions. Very big problem. Here, the standard transform is every time I am solving this, I've been giving you the standard transforms. Okay. Suppose this is, say, you have k. Suppose this is k and this is n. Fine. And you have a power k. So this would be 1 minus a to the power n plus 1 divided by 1 minus a for a not equal to 1. So z inverse is not equal to 1. Okay. So therefore, x of z can be written as, in place of a, we need to have z inverse. That's it. So it would be 1 minus z inverse. N, in place of n, we have 9. So it is 9 plus 1, right? So it is 10 divided by 1 minus a. 1 minus a means what? It is 1 minus z inverse, because z inverse is a. Fine. So further, this can be written as what in terms of z is the question. Further, it can be written as z to the power 10 minus 1 divided by z to the power 9 into z minus 1. So how is this possible? How is this possible? See here, this can be further written as 1 minus 1 by z to the power 10 divided by 1 minus 1 by z. Take the LCM. So it would be z to the power 10 minus 1 divided by z to the power 10. Okay. And you have z minus 1 divided by z. Understand that? So this z, so if you cancel this and this, you'll be left with z to the power 9. Fine. and these two you will multiply. So you will get this. I hope you followed this. Understand this, everybody? Okay. So this is what we do. So we have to sketch the what ROC for this. How to sketch the ROC for this is the question. So we have found out x of z. I hope you all followed this. This is how the x of z is. Okay. And since this is finite sequence, finite right-sided sequence. Okay. So let's write. Since the x of n is finite causal sequence. ROC is entire z plane with, except, it's not with, except, anybody? It's except z equal to 0. So this is ROC. So let's sketch ROC now. Let's sketch ROC. So for that sketching, let me just take the help of these. Fine. Then I'll take a circle from here. This is how the circle is. Circle is not very good, but still fine. Not a problem. Now see, this is the circle. Fine. And just can you tell me when could this x of z be infinite? When can this x of z be infinite? For what values of z this x of z would be infinite, and for what values of the z this x of z would be 0? Needs to be understood, because we have to give poles and zeros. Okay, so to give poles and zeros, it's fine. See here. So these are all lines we need to have, because it's entire z plane. They say entire z plane because it is finite sequence, except z equal to 0. So this is real z. This is imaginary z. So except z equal to 0, it's the whole z plane. Okay. So let's see how it is. Except z equal to 0 is what is understood, but that cannot be shown here. Entire z plane except z equal to 0 is the ROC. Fine. Now we have to mention the poles and zeros. What are poles? Poles are what? Poles are values of z or z values which make x of z infinity. Zeros are what? Zeros are values of z which make x of z 0. Understand that? So this is what we need to look at now. So how many such values of z are there? How many such values of z would make x of z 0? How many values of z would make x of z infinite? Now see here, in the denominator there are 9, z to the power 9. So any one z among this, if it is 0, then this x of z is infinite. That means if this z to the power 9 what we have, okay, so we can say all these z's if they are zeros, or any one of these z's if they are, if it is 0, that would make x of z infinite. So that means at z equal to 0 we have, let me take a different color, we have 9 poles. This is what? 9 poles at z equal to 0. And also x of z would be infinite when z is equal to 1, because if this z is equal to 1, it would be 1 minus 1, and that would again make x of z to be infinite. So that's why we have another pole at z equal to 1. So these are 9 poles at z equal to 0. This is one pole at z equal to 1. So these values will make x of z infinite. That's why they are called as poles, represented by what? This symbol. And zeros are represented by this symbol. How many such zeros are there now? Z to the power 10 minus 1. So this also can be 1 to the power 10. Understand that? So that means what? You have z minus 1, z minus 1, z minus 1 10 times. Okay. So 0 means what? There are 10 values of z equal to 1. There are 10 zeros at z equal to 1. So how to show that at 10 at sorry, how to show these 10 zeros at z equal to 1 is this. So we have one pole at z equal to 1. So here you will have a 0, a pole on a 0. Then we have 1, that is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now see this, if you have a pole and a 0 or 1 on the other, so this has to be cancelled. Okay, this will get cancelled. Okay, this pole and 0 will cancel each other. Since they are overlapping at z equal to 1. Since they are overlapping at z equal to 1, you will have this cancelled. So how many poles and zeros you will have finally? Okay, finally you will have 9 poles at z equal to 0. Okay, and one pole, sorry, 1 0. So in 1 0 or 10, again 9 zeros. Okay, 9 zeros at z equal to 1, magnitude z equal to 1. 9 0, because this pole and this 0 will be cancelled. So one pole at z equal to 1 is cancelled, and 1 0 at z equal to 1 is cancelled. Okay, so you are left with 9 zeros and 9 poles. 9 zeros at z equal to 1 and 9 poles at z equal to 0. Okay, so these are 9 poles overlapping on one another. Okay, in the same place there are 9 poles, and there are 9 what? Zeros, except this 0 and pole, because these pole and 0 will cancel each other. Okay, therefore since they are overlapping at z equal to 1, okay, these pole and 0. Fine. So this is how we have to do it. Fine. They have given us the second problem in this way. Okay, let's take the second problem now. Fine. So before we go to second problem, I think yeah. Now everybody having seen this, which let's take another problem. Okay, the second one. So this also would be a finite sequence. Okay, so we have taken problems on the final sequence now. So the second sequence that they are giving us this x of n equal to 1 comma 2 comma minus 1 comma 1. So this is what is the sequence, and here is your 0th sample. Fine. So in the solution we shall see how the things go. This again is finite sequence, mind you. Fine. So x of z is again given by summation n ranging from 0 to minus infinity to infinity x of n z to the power minus n. Okay, so x of n, since this is the equation, so we can expand it like this. Everybody see here, this can be written in expanded form since we have been given this. So it's starting from where this is 0th sequence, this is first sequence, okay, second and third. So this x of n is what? X of, okay, this is 0th, this is 0th, this is first, this is second, this is minus 1, n equal to minus 1. Fine, so this is the first sample is x of minus 1. Okay, so n is minus 1 means it would be minus of minus 1, so it is z to the power 1 plus x of 0 into z to the power 0, that would be 1, plus x of 1 into z to the power minus 1 plus x of 2 into z to the power minus 2. Fine. So therefore, if we substitute x of minus 1, the sample, okay, the sample is 1 here. This is 1. Okay. X of 0 is 2. X of 1 is 1. X of 2 is again 2. So how can I, sorry, this is what, this is minus, x of 1 is minus 1, right? Yeah, x of 1 is minus 1. This is 1. Is not, yeah. This is x of minus 1, x of 0, x of 1, and x of 2. Fine, that's why it can be written as z plus 2 minus z inverse plus z to the power minus 2, because this again is 1. So this is what we get our z transform of x of n to be. Okay, and since it is what finite sequence, okay, again we have to write the same reasoning. What is that reason? Since x of n is a finite sequence, okay, the and since it is both sided, right? Since it is a finite, it's not causal sequence. Finite double sided sequence it is. Fine. So what we have to do is this: finite double sided sequence, it is entire z plane except z equal to 0 and infinity. Okay, double sided. So we need to have double sided sequence here. For double sided sequence, you all know it is except z equal to 0 and z equal to infinity, because we have positive value of z as well as we have z in the numerator as well as z in the denominator. For denominator z, it's 0. For numerator z, it is infinity. Except these two, which will make x of z infinite. Rest, the whole entire z plane would be ROC. Okay. So how would we show that again? Here. So therefore, sketch of ROC. How we can do that? What did I do? Let's take this. And do we need to have a circle there? It's to be seen. Its entire z plane is what is understood. Here it's entire z plane. ROC is entire z plane. Okay. So here this is imaginary z and this is real set. Fine. Now, can we identify poles and zeros? We have this is one pole. Sorry, yeah, this is one zero. If this z is zero, x of z is zero. That's why we have this z, the one zero at this. Let me take a different color for that. One zero at z equal to zero. Fine. Then we have what? Two what? Poles again at z equal to zero. Two poles and a zero. So you can write two poles and a 0 at z equal to 0. This is how the things look like. Fine. Now let's move on with another problem. Okay, that is this the third one. Let me just give you that here. Third problem that we are seeing is x of n equal to half power n u of n minus u of n minus 10. So this again is finite sequence. Can you tell me what is the range of the sequence? Anybody? Okay. The range is range of this sequence is n equal to 0 to 9. Mind you, n minus 10 means you have this ranging from n 0 to 9. So it's half power n from 0 to 9. Understand that? So that is what is the thing that we need to understand here. Fine. Let's go now. So what is x of z? The solution, let's see. X of z is given by summation n ranging from minus infinity to plus infinity x of n z to the power minus n. Okay. Since x of n is half power n for n equal to 0 to 9, x of z would be written as here summation n ranging from minus infinity to plus infinity half power n into u of n minus u of n minus 10 is there, right? So this would become 1. Where exactly this would become 1? Here. N equal to 0 to 9. Okay. Half power n into 1. Because this is 1. Understand that. This is 1 from 0 to 9. Understand that? Or this can be told in another way. So instead of telling it here, let's just eliminate that. Okay, so let's say it this way. Since u of n minus u of n minus 10 is equal to 1 for n equal to 0 to 9, this implies this. Yeah. So let's say it this way. This implies x of z is equal to. This is how we can write. Is this okay with you, everybody? Now this is finite sequence and this is less than 1. So this is a standard finite sequence. Okay. So again, let's say we know that summation k ranging from 0 to n a power n is actually 1 minus a power n plus 1 divided by 1 minus a for a not equal to 1. So a is not equal to 1, it's half. Okay. Therefore, x of z would be what? 1 minus half to the power 9 plus 1. That's 10 divided by 1 minus half. Oh, where is that z inverse? I forgot that z inverse somewhere. See here? Nobody told me that. Nobody told me that. That z inverse has been forgotten. Here, that this z inverse is not taken. Okay, so that z inverse should come here. It's not z inverse, that's z to the power minus n, sorry. Yeah, z to the power minus n. This is z to the power minus n. Fine, so here you will have a z to the power minus n to deal with. Fine, so this has to be further written as, okay, summation n ranging from 0 to 9 half z inverse to the power n. That's it. So now a is half z inverse. Okay, so that's why this has to be written as what this has to be written as z inverse by 2. 1 by 2 z inverse 9 plus 1 divided by 1 by 2 z inverse, because a is 1 by 2 z inverse. Fine. So how can we write this further? So this can be further written as what? So if we take the, so it's half power 10 divided by z power 10. This is how it looks. Fine. So here you have 1 minus 1 by 2, okay, divided by z, you can say, not a problem. 1 by 2z you can write in the denominator, or you can just go, okay, down like this. So it would be z to the power 10 minus half to the power 10 divided by z to the power 10. Then this is z minus half by z. So this and this cancelled will give you z to the power 9 here. Fine. So this can be, therefore, x of z can be written as z to the power 10 minus half to the power 10 divided by z to the power 9 into z minus half. Understand? So this is also a right-sided sequence, mind you. This is also a right-sided sequence. So what we can say, the same statement can be repeated. Okay, since x of n is a finite causal sequence because it is right-sided. Okay, since it is causal sequence, okay, so we can write the ROC is entire z plane except z equal to 0. So this is your x of z, and ROC is this. Now we need to sketch how many poles and how many zeros are there, needs to be understood. Fine, similar to the problem that we have done earlier. Fine, so let's sketch and let's see how many of you can tell me that. I think I can take this in a different color. Possible? Let's do this. Fine. Okay, fine. So this is how it looks like. This is imaginary Z and this is real Z. Since it's entire Z plane, okay, let me take a different color. So it's entire Z plane, mind you. Except Z equal to 0. This is ROC, except Z equal to 0. Fine. So, which values of Z would make X of Z 0? Which values of Z would make X of Z infinite? Okay. So these 9 Zs at Z equal to 0 will make it infinite. So 9 poles at Z equal to 0, 1 pole at Z equal to half, then 10 zeros at Z equal to half. Okay, so 1 pole and 1 0 at Z equal to half will cancel each other. That is this. So let me take another. Don't know this would be visible or not. Here you have 1 pole and a 0, and you have this will cancel each other. So you'll be left with what? 9 poles at Z equal to 0. Okay, 9 poles are there. So this is 9 poles at Z equal to 0 and 1 pole at Z equal to what? Half. This is half, mind you. Fine. Then 10 zeros at Z equal to 0. That means this is 1 0 which has cancelled. We need to write 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 zeros at Z equal to half. Fine. So this is how we need to do the problem.